Okay, so in this video, we're going to be talking about the arc length function, okay? In the past couple videos, we've been talking about arc length, so it's only fitting that we mention the arc length function as well. So what if we're asked, find the arc length function of the graph y equals x squared minus 1 over 8 natural log of x starting from x equals 1. So first off, to answer this question, we need to address what is an arc length function. Well, it's simply a function that, like it could be like 2x plus 2, something like that. It's going to give you the arc length depending on what x you put in, okay? What's your end bound, okay? Because we're going to be starting from a known point, okay? And we're going to be ending at some x, okay? So the formula for this is now to find the arc length function, we're going to use the integral from a to x, okay? Not the integral from a to b, okay? Because x is just going to stay x. We don't have a value for x, okay? But for a, we know that that's 1. So we're going to have the square root of 1 plus dy dx, quantity squared, and we're going to have a dx on the end. Now, we can have dx dy and a dy here, okay? But that's if our bounds are on the y-axis, of course. Now, to solve this problem, the first thing we need to do, just like the arc length, is find our dy dx. At least that's what I suggest. Dy dx is going to be 2x minus 1 over 8x. All right? And dy dx squared would just be a FOIL. When we FOIL that, 2x times 2x, it's going to be 4x squared. If we multiply these two things, well, 2x over 8x, that's just going to be 1 over 4. So you have two of those, it's going to be minus 1/2. And this 1 over 8x, that's going to be squared, so it's going to give us 1 over 64x squared. So now we know our dy dx squared. And we can plug that in to our arc length formula to get that the arc length is the integral from 1 to x of the square root of 1 plus 4x squared minus 1/2 plus 1 over 64x squared dx. Okay, we can combine like terms here to get that the arc length is the integral from 1 to x of the square root of 1/2. Actually, we can rewrite this. It might be a little better to write it as 4x squared plus 1/2 plus 1 over 64x squared. Then you might be wondering, okay, where do we even go from here? Well, we can try to factor this actually. And it's actually going to be pretty easy to try to factor it, because this is literally just the square root of 2x plus 1 over 8x quantity squared, okay? So, yeah, you see these two pieces right here. So I got 2x because that's the square root of 4x squared. And then 1 over 64x squared, you take the square root of that to get 1 over 8x, okay? And when you end up foiling that out, that just happens to give you a 1/2 as well in the center because of kind of what we did before, right? You can kind of see that, okay? So anyways, that square is going to eliminate the square root. Don't want to forget that dx. So we're going to end up with the arc length being the integral from 1 to x of 2x plus 1 over 8x dx. So now we're taking it up here. We're going to get that the arc length is equal to x squared plus, this will be 1 over 8 natural log of x. This will be evaluated from 1 to x. Okay, so we're going to get, we do our evaluation step. The arc length is equal to x squared plus 1 over 8 natural log of x. And now we're going to plug in 1. So we'll get minus a 1 squared, which will be 1, plus 1 over 8 natural log of 1. Now we know that natural log of 1 is going to be 0. Okay, and we just have that 1 there. So what's going to end up happening is we'll get that the arc length, and we can put this as a function of x. If you want to write it like that, it's fine. is going to be equal to x squared plus 1 over 8 natural log of x minus 1. Alright, and that's your arc length function. So you can put in any x, like say 2, okay, and then your interval becomes 1 to 2, and you have your answer, because you can just plug it into this function rather than taking the integral again and doing the whole process. Alright, so that's what the arc length function is, that's how to find it, and that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for more applications of integration in the next video in the series. See you soon.